Right, there are 4 questions I want to share with you in the quiz on indices, and these questions are 9, 15, 17, and 18. So please pay particular attention to these questions, and particularly the later questions like 15, 17, 18. So here's the first question here, question number 9. Now we see that the 2 to the power of n plus 4, and is also somewhere in other terms got 2 to the n as well. So maybe we could express them in a different way so you can see it more clearly. So what we can do is to break up the n plus 4. So you see the n plus 4 now becomes 2 to the n times 2 to the 4. And again, the 2 times 2 to the n all over 2 to the n and times 2 to the 3. Okay, so instead of a plus now I got all these multiplications. Now you can from this point see that there are common terms on the numerator. So we could take out these common terms, see if you can spot them. So they are 2 and 2 to the n, because that's the smallest power we have here. So always take out the smallest power for your common term. So the smallest power is 2 to the 1, and same as 2 to the n. Now we see that some of the terms can cancel each other out. So now we get 2 to the power of 3 minus 1, which is 8 minus 1, which gives us 7, and 2 to the power of 3 is 8. So the answer should be A, 7 over 8. And here's question number 15. In here, we need to find out which one here must be true. So we need to test each of these one by one. I'm comparing the terms here on the left of the equation and also on the right of the expression here. So anything to a power of 0 must be 1. So the terms on the right turns out to be 1 plus 1. But on the left, a plus b all to a power of 0 is 1. So hence, the left does not equal to the right. So the statement number 1 is incorrect. Now where's statement number 2? We got a to the minus 1 plus b to the minus 1. And does that equal to a plus b? So let's check it out. So a to the power minus 1 means 1 over. And all that 1 over again. So common denominator in this case is ab. So we now have an expression of a plus b over ab, all to the power of minus 1. And to convert that minus 1, we turn the numerator and the denominator upside down. So now we have our numerator as ab and the denominator as a plus b. Clearly, this does not equal a plus b. So again, statement 2 is incorrect. So let's check out statement 3. So a to 3, b to 3, does that equal to ab or to the power of 6? Now, if we take out the power of 3, we see that ab to the power of 3. Clearly, again, this does not equal to ab to the power of 6. So again, statement 3 is also incorrect. And for this question, the correct answer here must be D, none of them. Now we have question number 17. Looking at this question, we see that there's some connection in terms of the power. They all got n, and that one of the base is 3 and the other base is 9. So the 9 could be thought of as 3 to the square. So let's take a look and isolate some of the terms and see if we could simplify the problem. So separating the 2n, and that makes 2 to the 2 to the power of n, and the 9 is 3 to the square all to the power of n, over 3 to the n. Now they all got n here to the power, so actually I could have a bigger bracket and take up the n as the power for the whole term. Now in this case that leaves me with just 2 to the square, which is 4, and then 3 to the square over 3. And again we can simplify, and the 3 cancel each other out. That leaves me simply with 4 times 3 to the power n, and which is answer C. Now the last question here is question 18. Note that first the condition is that a does not equal 0, because otherwise our base will be 0, then everything else will be correct in terms of expression. So what we have, a to the n minus 2, and again a to the n of minus 1, all over again a to the n minus 2. So what we can do here is to take out some common term. So if you can't see a common term, then maybe first we remove the expression and change that to be a product. So instead of having a to the n of minus 2 and a to the n minus 1, so we could have a to the n times a to the power minus 2. You see here? So now simplify the problem by putting them in terms as a product. Now here we see that on top of the numerator here we have a to the power of n, and they are a common term. And again, both of these terms is got a to the power minus. So what we do here, we always take out the terms with the lowest power. And the lowest power here is a to the minus 2. So we take out a to the n and a to the power of minus 2. Now at this point we can always check and make sure that we are not making any mistake. And if you do multiply a to the n and a to the power minus 2 into the bracket, you should get the same term as above. Now we see that a to the n and a to the minus 2 can actually cancel each other out. And that leaves me with 1 plus a, which is answer C. Thank you very much for watching. Hope you enjoy. Let me know if you want to practice more. Bye for now.